Okay, so I hope you enjoyed my little mini Miko video. That is what I'm having to deal with right now while I make these videos. It's a little needy, but he's so cute. Yes, he is. Alright, I'm going to do a couple of these ones. I feel like all the other ones on the other page are really straightforward. So I'm going to go through and do maybe a couple for this video. This might be a little longer. So number 11, let's start with that one. I gave you the side length here because I felt like it would be a little... oh, that's not accurate. I'm so sorry. This whole side length should be 18. I think that's what your review says. 18 square root of 3. Ooh, that's not good. Okay, well, hopefully your review had the correct thing there. So since this is a triangle, there's a couple ways we can do this, but it's a regular triangle. All these are regular, by the way. So I'm going to be using the 1/2 AP, or actually, as I like to write it, AP over 2. Okay, but what I don't have here is the apothem. However, if I draw this from here to here, I can find that because of what I know about special right triangles. Yay! Now, how do I know this is a special right triangle? Ms. Coffee, you told us that we can't assume anything about the angles. And you're right, we cannot. However, if you think about the triangles in this triangle, triangleception. Get it? Do you see what I did there? Triangles, everything is about triangles. I'm going to make them different colors. So why not? You're going to be so tired of my voice after all these videos. Okay. So look at that. We have a really pretty, beautiful triangle split into 3 triangles that are all equal. What if I wanted to find the angle of one of those triangles right there? I would do 360 divided by how many there are? 3. So that's 120, right? So that's my angle here. That represents this whole angle, but when I draw the apothem right there, I'm cutting the 120 in half, which is 60. So what I have here, I'm going to kind of erase and then I'll redraw my apothem. So this angle here, okay, that's enough. Hey, Miko. Sorry, when he drinks too much too quickly, then he just throws out the water. I know, it's disgusting. Children. Okay, so 60 right there is half of 120. So that's how I know for sure this is a special right triangle. So what I'm going to do is I'm going to redraw that triangle but larger so I can take a look at it. I'm wanting to find the apothem. This 18, if you can't tell, is actually referring to the radius, which is right here. Okay, and I gave you this whole side length, even though you should be able to get it even if I didn't give you that, because you know the rules. So this is 2x, this is x, and this is x square root of 3. That's our rules for 30, 60, 90. So if 18 is 2x, that means half of 18 is going to be the x right here. So the apothem is 9, which means that the long leg is 9 square root of 3. So that represents just this part right here. And then, so that's 9 square root of 3, which is why the entire length should be 18 square root of 3. Okay? But since I gave that to you, all you had to find was the apothem. So you could have used either the 18 or the 9 square root of 3 to find the apothem. So now that we know the apothem is 9, I can plug into my formula. So, I need to make sure we do perimeter. Perimeter is a little different here. It's still going to be the number of sides. Here, I'll write it like this. Number of sides times the side length. But the number of sides is 3, and the side length is 18 square root of 3. It's just kind of weird. Okay? But that's okay. It's still going to be, you know, we'll just keep it in simplest radical form because that's what I want you to do here. So that's going to be 54 square root of 3 for the perimeter. And then you do your formula. AP over 2 is going to be, apothem is 9. Perimeter is 54 square root of 3. And then all over 2. So we're going to multiply 9 and 54, which is 486 square root of 3. Divide that by 2. And we get 243 square root of 3 for the area of this regular polygon, which happens to be a regular triangle. Kind of a lot going on there. Yeah? Okay, so with that in mind, let's see if we can do number 12 together. Or maybe I'll just give you a little tiny piece of it. I won't do it all for you. Okay, I gave you the apothem, which is nice. So my formula, apothem, times perimeter over 2. Apothem is 4 square root 3. But what is the perimeter? Perimeter is the number of sides times the side length. The number of sides is 6 because it's a hexagon, but I don't have the whole side length. But guess what? I can find it. So if I draw in a triangle, surprise, surprise, inside of my hexagon, guess what kind of triangle that is? It's a 30, 60, 90. But wait, we can't assume that, so how do we know? Same process over here, 360 divided by blah, 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 blah. So if I do 360 divided by the number of sides, that's going to be 6. That gives me 60 degrees. That represents, like if I were to draw this radius, here's my 60. But when I draw my apothem in to cut that in half, boop, I'm doing 60 divided by 2, which is 30. So this angle right here is 30, which makes the other one 60, right? 30, 60, 90. So that means this is x square root 3, and this is 2x. So if 4 square root of 3 is given to me, and that's my apothem, and it's my long leg, well, think about it. 4 square root of 3 is equal to x square root 3. Divide both sides by square root of 3. Then what does x have to be? 4. Just 4. So that means this piece is 4. That means the radius is twice that, which is 8. But mainly, it means that the side length here is 4 plus 4, which is 8. So I now have my side length is 8. My number of sides is 6, so I can plug that in to find perimeter, which is 48. So now I can do 4 square root 3 times perimeter, 48, divide by 2. So I'm going to do 48 times 2, and then divide that by 2. Guess what that's going to be? It's going to be, oh, did I do 48 times? Sorry, 48 times 4 is 192. I'm getting ahead of myself here. Divide that by 2, and that's going to be 96 square root of 3 for the area of my hexagon. Oh man, I told you I wasn't going to do this for you. Oops. Okay, you get the picture, right? Okay, so number 14, you can totally do that on your own now that I've showed you how to do 11 and 12. Number 10 is a little tricky. What I would suggest is, for this one, I hope you're watching this video. For this one, you can use the AP over 2, or I could use the regular formula for area of a triangle, which is base times height over 2. Because if this is an equilateral triangle, which it is because it told you all these are regular polygons, and then I draw in the height, like so, all of these angles are 60, because it's equilateral, but when I cut the height there, it's cutting that angle into 30 and 30. So I have another 30, 60, 90 triangle, but it doesn't have anything to do with the apothem. We have the height here, yes? So if I know that this piece is 5, right, because it's half of 10, the whole thing is 10, then what does the height have to be? 5 square root of 3, that's right. And then it's just base, which is 10, times height, which is 5 square root of 3, divide by 2. So maybe don't use AP over 2 for number 13. That's all I'm saying. For 14, you should. You have to. Okay, that's all I'm going to do on this page. You don't have to do these, but I do have the answer keys on, I think, on my website if you want to check. Just to try it out, you know, for funsies. Okay? All right, let's pause.